Have you ever stopped to wonder why those beautiful, clear blue tropical oceans, the ones you see in pictures, seem, well, almost empty compared to cold, murky polar seas? Those places are just teeming with life. It's a bit strange, isn't it?
It really is. And the answer, interestingly enough, involves a pretty fundamental principle of physics. But it's also tied into some quite alarming global trends we're seeing now.
Okay, let's get into this then. Today we're doing a deep dive into dissolved oxygen in the ocean. It's basically, well, essential air for marine animals.
That's right.
And we're drawing on some solid research here, things like the findings in oceanic deoxygenation, a global warning. Our goal really is to figure out how this basic physical rule is interacting with, current global changes and potentially creating some really serious problems for marine life.
Exactly. And the core idea is surprisingly straightforward. It's just that colder water can hold more dissolved oxygen than warm water can. It's established physics.
Okay.
And that's a big reason why those freezing polar seas are so incredibly productive, supporting huge food webs. While the warmer tropical waters, clear as they are, seem less populated. Makes you look at those postcards differently, doesn't it?
It really does. So, all right, if ocean temperatures are rising globally, which we know they are, what's that doing to the oxygen? Is it just like a simple proportional drop?
There is definitely a drop. That's a direct effect. As the oceans get warmer because of climate change, they just physically can't hold as much oxygen. But, and this is the really crucial part, and quite concerning. Scientists have looked at data stretching back, more than 50 years, and what they're finding is that the dissolved oxygen in the oceans, it's actually been decreasing faster than you'd expect just from the rise in water temperature alone.
Wait, hang on. So it's not a one-to-one thing. The oxygen loss is actually outpacing the temperature rise. That seems important. Why is that happening? What do scientists think is driving that faster decline?
That's the key question, and the leading theory points towards increased ocean stratification. Basically, think of the warmer surface water acting like a kind of lid.
Okay, like a barrier.
Exactly. It makes it harder for the ocean layers to mix. So this lid stops oxygen from the atmosphere getting mixed down into the deeper waters where so many creatures need it. It's effectively suffocating parts of the deep ocean.
Right, I see. So what are the consequences then? When oxygen levels fall too low, what's the actual, real-world impact on marine life?
Oh, the impacts are profound. Marine organisms everywhere are finding their homes affected, sometimes becoming completely uninhabitable. We've seen more frequent anoxic events recently.
Anoxic events?
Yeah, periods where the oxygen is so low that it either forces out or just kills off large numbers of fish, crabs, loads of other organisms. We're seeing actual mass die-offs, and that obviously disrupts whole ecosystems and the local economies that depend on them, too.
That's incredibly serious. So just to kind of quickly sum it up for you listening, the basic physics is colder water holds more oxygen.
Yeah.
Global warming is making oceans warmer, so they hold less oxygen. But crucially, this oxygen decline is happening faster than the temperature rise alone would cause, partly because of this stratification, this layering effect. And this leads to these dangerous anoxic events that suffocate or push out marine life like fish and crabs.
Yeah, and if you connect that to the really big picture, it's pretty clear the health of our oceans and, global well-being are tightly linked. These changes in oxygen threatening entire ecosystems, they're going to have wider ripple effects. We're probably only just starting to grasp the full extent. So maybe the thought to leave you with is about that interconnectedness. What are the long-term implications for biodiversity, for those complex marine food webs, and ultimately for the whole planet? What are those sort of unseen consequences beyond the immediate die-offs going to be, and how might these big ecosystem shifts really reshape things? Something to think about.